Hello everyone, my name is Omer Yildiran. I'm a PhD student at New York University NYU. I'm working with Michael Landy and I'm working on time perception and multisensory integration. Today I would like to show you polynomial regression, which is just an extension to linear regression. And why do we need to use it? Because it's linear regression, although it is predicting the results, predicting the responses, it doesn't usually fit to neural spikes, for instance, for the duration estimation tasks, for instance, because we can estimate the duration shorter at the beginning, longer at the end. So who knows? We need more complex models to see even. So let's have a look at the linear one actually to just demonstrate. It is just also a polynomial regression model. So when we look at the theta 0, we ignored that, but there is actually a theta 0 times x to the power of 0, which is resulting in 1. That's why we ignored. And here, x to the power of 1. We just ignore the power. But in the polynomial regression, you can see theta 1, theta 2, and here x to the power of 3, 3. And when we see it like 3, we can say that it is a third order polynomial. And still, the thing we are dealing is the same. We need to have a design matrix and a theta parameter space, parameter vector. When we multiply these two, we acquire the responses. And in normal linear regression, the first column is just consisting of the ones. Second column is consisting of the axes, the features. But in the first order, you see 1, 1, 1, 1. But we need to have for the polynomial at second order or third order or kth order. I'm not going to add the kth order, but you can if you have a polynomial to the kth order function. And here, when we multiply these two matrices, what we will acquire? I am adding the rest of the terms. So theta 0 multiplied by 1, theta 0 added in here. Theta 1 multiplied by x1 come in here. We are getting theta 2, the other parameter, with theta 2 to the x to the power of 2. We need to have theta 3 times x to the power of 3. And it goes like that. It is the same for all the others. And you see, this is similar to that, right? Just we have the epsilon. So let's have a look at the coding stuff a little bit. Let me run this. What we are doing in here, we are just doing a simulation data, creating the simulation data with x's and y's. X's are the features, y's are the responses. Once and again, a reminder. What does it look like? It doesn't look like they are linear, correlated, or there is a real relation between this x, y. It looks like it is more like a parabola. So how do we do that? We need to create this design matrix. We need to stack the degrees, ones, x's, x to the power of 2's, x to the power of 3's. How do we do that? Here, we are creating this function, definition, make design matrix. We need to get rid of this race error. We need to implement nph stack design matrix with x to the power of degree. And it will give us the theta parameters. No, the design matrix.